All right, hello. I am Ryan Torvik with Tulip Tree Technology, and this is,
Hi, I'm Tim Guy from Magpie Embedded.
and we're here today to talk about what I don't know, we started with Embedded World 2025 and beyond. Let's get started. All right, you start.
Let's see
Let's
what
do it.
happens.
What did you? Is this the first time you've been? You've been there a number of times.
Yeah, so I've been to Embedded World the last 4 or 5 years now, I think. And it's a little bit different every year, right? There's different trends on display. Some people's stands are getting bigger, some people's stands are getting a little bit smaller.
Some people's
It's
stands are not
interesting to
even
see.
there at all. Like I looked at past and I'm like, wait, where are these guys? Why aren't they here anymore? They're still in
Yeah,
business. Why
that's
aren't
what
they
we
here?
talked about. Even Microsoft and Amazon have been there in past years with pretty big stands, and neither of them were there this year. They, Microsoft got rid of ThreadX, which is now with the Eclipse Foundation, and Amazon still owns FreeRTOS, which is still a very widely
Yeah.
used operating system. And in the past, they've been at Embedded World showing that off with their middleware, and they weren't there um, at all this year. So I don't know how well that bodes for FreeRTOS. Um, but yeah, I mean, I think the Zephyr stand was probably getting a little bit bigger, right?
Yeah.
There were definitely some of those AI applications at the edge on display. But I think I said to you at the time, I think the trends were a little bit muted this year. There wasn't one trend that was kind of dominating the conference in the way it has in the past. So I think the size of the conference is pretty much the same the last few years that I've been as well, the overall size. Um, so I think, maybe there's some room to grow in the future, but it's still probably the biggest conference that's focused on embedded systems, right? And it covers, I mean, more or less the whole ecosystem, I would say,
There's a lot. There was a lot.
in terms of I guess you've got all the chip vendors, even people there to help you make custom chips or help you get certain things manufactured in China or abroad. And then, yeah, all the way up through kind of microchip, TI, NXP, all those kind of people, peripheral manufacturers doing certain sensors or camera modules or connectors. And then, like I said, the firmware layers of um, and all of the tooling that goes with it. So static analysis tools, compilers, um, and then the kind of higher level CI infrastructure type companies as well coming online, and people doing OTA and fleet management and all of that kind of thing. So I mean, that's pretty much everything that we do in embedded systems, and there's going to be quite a few people there talking about it.
Yeah.
So what was your impression?
I mean, well, and so first time heading over there, and yeah, I mean, I didn't really know what to expect, and yeah, as you point out, like it's everything from individual, not quite pushing electrons around, but like very low level. I was really excited to meet with the Cherry team where they are
Mm-hmm.
developing their own chipset, which has different sets of instructions that make it so it's make it so that pointers actually have meaning. Like there's some like getting to chat with those guys and seeing like that level of like caring about how things work, and then all the way up through CI/CD, and then people bringing like robot vacuums around and just kind of like I actually didn't spend a lot of time at the bigger booths to see kind of like what they were doing. I was much more interested in the process level and kind of
Yeah.
like the firmware development and then the security guys there too that were there. So like so what was different this year? You mentioned some people weren't there that were there before. Like what was different this year than it was like last year, the year before?
Well, that's what I was saying. I mean, in the past few years, things like cybersecurity and Rust have had really big pushes, I would say.
Yeah, yeah.
And this year, I felt like everyone was kind of doing their own thing, and those
Mm,
trends had gone from
interesting.
being um, taking over the entire stand from any given vendor to being more of a bullet point
Yeah.
on their presentation, right? So we still had Rust and Zephyr and cybersecurity were all kind of being mentioned. Probably some more mentions when I first walked in for the Cyber Resilience Act, which is coming in the EU.
Yep.
I think it's kind of already in use, and it's going to be enforced more
Yeah.
over the next few years. And you don't have to go very far to see presentations from people saying you're probably not ready for this yet because a lot of people are going to be quite far behind in terms of having the tooling in place to enforce that. So I think that was one of the newer things. And yeah, there were, like I said, edge AI applications. I think that's making its way now, probably from being a demo at one of these conferences to being something that is seeing a bit more use actually in the industry, right? And then I guess that's interesting, kind of when it actually stops being pushed at these exhibitions as much, because the companies can't necessarily talk as much about what they're doing, right? Or it might not be as obviously interesting of an application, but it's kind of starting to bring costs down or
Yeah.
allow you to iterate the program more quickly, right? And the firmware, and get things to market more quickly. But that's quite hard to demonstrate on a stand.
Yeah. Oh yeah.
So I did say to people the Edge Impulse, which is probably one of the more visible companies in that space. You know, they do a lot of really good outreach and demos, and they were acquired by Qualcomm, which was announced right at the start of the conference.
Oh, okay.
So Qualcomm last year, they announced their acquisition of Foundries IO
Yep.
at the start of the conference as well. So if you are watching out for Qualcomm news, this is kind of a time when they tend to announce something or other.
So if I want to
But I
get
mean,
acquired
it
by
does show you that.
Qualcomm, okay, so like, if I had to put them on my timeline, if I want to be acquired by Qualcomm, I have to be ready to be announced in March. Got it.
Yeah, I think that they're going to give you some materials if they acquire you. I don't think you need to worry about that one too much. But it is interesting because, you know, I wasn't sure exactly how big or important Edge Impulse are. Like I said, they're always at conferences and doing outreach. But for a company like Qualcomm to take note of them and acquire them and bring them in, you know, they must be making some waves and interest. And that shows you where a big company like that is going to try and have that end-to-end support, right?
Yeah.
So the Edge Impulse is give us data and you can tune some parameters and then we'll give you an AI model. And then on the other side is the Foundries IO for doing deployment and
Yep.
fleet management. And then Qualcomm is in the middle saying, well, you can use our chips and you can use our signal processing libraries and knowledge and all of those kind of things. So they're envisioning that end-to-end thing. And there must be other companies looking at the same
Oh yeah.
sort of model.
Well, and so from my standpoint, I was really excited. I chatted quite a bit with the Foundries guys, just to kind of like understand everything that they're pushing for and they're doing. And I think a big thing that with talking with people is that a lot of the vendors were pushing, as you mentioned, kind of the process. A lot of them were pushing the process to become compliant. Here's the CRA, it's coming. Here's the process you need to follow in order to make sure you're compliant with the requirements that are there. Here's how you make sure you're compliant with MISRA C. Here's your code compliant. Here's your code coverage tools to make sure you're compliant with the automotive requirements and everything else. So I saw a lot of that process, but then talking with people who were not in the booths, who were just kind of walking around on the floor, the people on the floor weren't doing the things that the vendors were selling. Like, so I'm like, oh, because I was like, wow, you guys are really far. Like the industry is so much further ahead than I thought they were. And then, you know, you talk to the people on the floor, and as you mentioned, like, oh, you guys are probably not ready for this, which is why people are pushing it so hard now, because this is coming online. You know, I don't know if you saw a group called Code Intelligence. They do automated fuzzing generation by AI. And I'm talking to them, I'm like, who comes to your booth, guys? Like, I'm excited to see you. I'm very excited to see you. But like, who, and, you know, they're like, well, we're more geared towards automotive because automotive has compliance requirements for that. So like, we get some here, but we're the automotive conferences are bigger for us. And it's like, because I am excited to see people do automated fuzz testing. in in the development loop. Like this is definitely a thing that needs to happen. But we're having trouble getting software people to do it, let alone trying to get embedded systems. So, and I had people telling me that embedded development is like 10 years behind regular software development. So, like this is kind of like, okay, we're getting there, we're getting there. Did you watch? I sat down with IAR and talked to
Mhm.
them about their compilers, and then I listened to one of the talks from Darwin that he gave about GitLab and their hardware in the loop testing. Did you get a chance to talk with them or check that stuff out at all?
Yeah, I mean, GitLab was one of the companies. I don't think they've been there before.
Yeah.
So they didn't have a massive stand, but they did have an interesting stand and some big hitters, I guess. And I guess in some ways they've kind of fallen into this market because embedded CI is not it's not always been the default in this industry,
Yeah.
right? And I suppose in some ways it still isn't. But I think what's happened is definitely in my experience, people that have come from a more software focused background come into embedded and said, we really need this. And what's going to be the easiest way to get this set up, potentially with some on-prem or not. And GitLab and the GitLab CI model has been picked up really quickly by engineers. And then people are using that tool to do integration testing, hardware in the loop testing, these sorts of things. Right. But GitLab is not designed from the ground up for an embedded use case.
No.
I think they've just seen that it is probably a growing space, and if they can continue to support it, and they had demos there with hardware in the loop testing running on a Raspberry Pi kind of thing, as a demonstration of how I guess you can do it in a straightforward manner. And so I think, yeah, from their point of view, they just want to be the number one choice probably for engineers or for people, looking to introduce this in their company. But then you are getting some companies start to come over the top and try and combine these tools together
Hmm.
and provide a more embedded focused approach, right? And I think that's where I think there definitely is value to be had there, both for the companies doing it and for engineers, so that not every single company and engineer has their own half-baked,
Oh my gosh.
implementation. Well, I mean, you talked about the automated fuzz testing or something like that, right? So you can see the value in potentially just being able to drop that in to your kind of CI pipeline,
Absolutely.
and have that basically just set up and ready to go from day one, rather than having to start reading through documentation, how to install it, how to set it up, how to get the results out and do the
Oh my
measurements and
gosh.
review your progress and those sorts of things. And that, yeah, I think that push is coming from the software side, but there are enough people now looking at it and saying that there's an opportunity here to provide a service that's useful to a lot of different embedded systems engineers and companies.
Oh, absolutely. I mean, we're banking on that. Like that's kind of where we're coming from too, because one of the we believe that so coming from an offensive cybersecurity side, like the reason that we believe that the devices are so easy to knock over is because they haven't been developed with these kinds of technologies and techniques. Like,
Yeah,
you look at people like the bigger companies on the software side, like the reason that your phone is as stable as it is because they invested a ton of money in making sure that they have an effective development life cycle, and that
yeah,
they've got an effective way. It's designed to be tested. It's designed to be tested in a way that makes it so they can do that automated fuzz testing. And so if you're not thinking about that at all, then you're not going to be there. And so I think I was really excited to see the number of companies that were really kind of pushing that and kind of moving in that direction. Now, you went to a number of the talks too, right?
yeah. I didn't go to so there is a conference attached to
Oh,
Embedded
okay.
World as well, which is sometimes when you go on the website, it's a bit confusing because you have
I
Embedded
wasn't
World
confused at all.
exhibition and then the Embedded World conference, which
Yeah.
is off to the side in one of the halls, and they have talks going all day. So I didn't go to that.
Oh, okay.
I went to some workshops on the Wednesday. So there was one from Analog Devices, who were doing a Zephyr workshop and demonstrating integration with their tools and basically showing that they're taking a Zephyr first approach, I suppose. So I see that as kind of following in the NXP,
Yeah.
in the Nordic footsteps,
Okay.
right?
Yeah.
And providing that tooling first up. It was also just interesting to hear them talking about their MCUs, because Analog's not a company I think of for MCUs. First of all, I normally think
Right.
about peripherals and sensors, but they were
Yep.
there trying to emphasize, no, we are selling processors as well, and it's going to be Zephyr first. So again, that's another demonstration of Zephyr's growth, that other companies are jumping on top of this, right? And it's not seen as big of a risk as it was when Nordic took that approach, to do Zephyr first and have that as a real emphasis, instead of providing their own IDE and all of these kind of things. So that was quite cool. And then there was one from Microchip showing off their processor, which had 5 RISC-V cores on it. And the ultimate aim of that workshop was to get some heterogeneous computing going. So have Linux running on 3 of those cores and Zephyr running on the other core, and having some communication going between them, which I think it still needs some work in terms of making it a little bit smoother.
Yeah.
But I've been quite interested by that approach for a little while, because I think it could make a lot of sense in terms of getting projects working and ready for market more quickly, to separate the real-time components and the onboard peripherals and sensors and so on, which get a lot of good support from Zephyr specifically, but also might have genuine hard real-time requirements, and then allow you to leverage the power of the embedded Linux side for doing your processing, and basically develop with the same tools that you're then actually going to deploy.
Yep.
Right, in terms of data analysis or databases, all of your connections, all of those kind of things.
Right.
And I mean, potentially from a security point of view, that would have some benefits, right? Because instead of having to use embedded or MCU focused libraries, which maybe don't always have full support or as much attention, you can just use the Linux ready tools or production ready tools that you would have on your development machine, right?
Oh yeah.
And leverage those in your product.
That's, when you look at, if you're doing an attack surface analysis of a system and you're like, okay, I want to find a bug in the system. What do I look for? Where's the first place I look? I look for things that are under supported. I don't go and be like, okay, Microsoft is actively pushing out patches and releases for this because they care a lot about the safety and security of this thing and make sure it's up to date. So I'm not going after something like Chrome or Firefox to start off with. I'm going after that one media library that plays MP3s or MP4s that somebody used, pulled in off the internet, downloaded from GitHub and just included it in their thing. Like, that's what I'm looking for. I'm looking for, what are these weird libraries that aren't really well supported by a large community, that don't have that security first, and that just kind of like, oh, we threw it together. Like, I'm still new to the embedded system, so like, do you run a web server on an RTOS? Is that like a good idea? Or do you write your own kind of, like, if you need web connectivity, do you write your own web server? Do you write that kind of application and try to cram it into an RTOS or an MCU? Or how do you handle that? Because I would rather you do that in Linux, because Linux is like good at that.
Yeah, I think there are different approaches, and to be honest, it probably depends who specifically you talk to and what experience they have doing that on different projects before, more than it necessarily depends on, is this the right choice for our product or project, right? People can and do run web servers and clients on MCUs, and if you've seen any of the IoT exploits showing people hacking an entire building full of lights and playing Tetris on it or things like that, it's from those sorts of implementations.
Yes.
Which is a mixture of, potentially some people are rolling their own, some people are going online and finding a useful library, but not necessarily having enough knowledge to configure it properly. And this, goes back to a little bit what you were saying earlier about having these tools kind of on by default and some of the compliance requirements that are coming in, because embedded developers by and large are not also network and security experts, but they happen, we do that as part of our jobs, right? This is one of the places where those default settings and examples really matter, because even on the software side, there's a lot of cases where examples have unencrypted passwords left in the source code, for example, and people deploy that right onto open source applications where anybody can then go and look at that. So if you take that same approach, but you put it in firmware and you ship that around the world to lots of different devices, you've got the same problem, but it's a lot harder to fix. Right. One of the things that is part of the CRA initiative is no more default passwords. So every device has to have a unique password. And you can set that and put it on a sticker on the device and send that out. And that's going to be a lot better, right? But I think that just speaks to, people being pushed to get things out the door, to get things connected, without necessarily having the time or expertise or ability to get in touch with people who really know what they're doing.
You'll get historically, like embedded Linux was kind of a joke. Not even kind of a joke. It was just completely a joke, especially in the security. It's like, oh, no, another version of Linux that isn't implemented and doesn't have, but you look at, and I'm so glad to see a company like Foundries come out and be like, we'll give you a Linux that is designed to be secure and updatable and doesn't have the problems. Like, we'll take care of that part of it for you. So you can still have your embedded Linux underneath the hood, but at least it's got some firmness to it, so you can actually, you should trust it. So let's talk a little bit about what people are doing with AI. You mentioned AI on the edge, which is like, okay, so you took an MCU and you put it on the outside of a tractor, I guess. I don't know, like what do we we got a GPU and we put it on the outside of a tractor. This is the edge. Where are people using AI in this space? And I think this is a longer conversation. I know Jacob's really excited to talk about it at the embedded conference. So,
I don't have excellent knowledge or insight into that. I think it's one of those things, like I said, that's coming along over the years, and it's seeing a bit more usage. Edge is one of those words that means different things to different people. And I've heard about, we had the IoT with the cloud, right? And then there's fog computing, which is kind of on the boundary between these things. And if in the simplest application, I suppose, edge just means using AI on a microcontroller at all. And that could be for just picking out signals in your time series data. So okay, it's on the side of a tractor measuring temperature, and when you see something abnormal, you want to flag something. So rather than using traditional DSP techniques, you're going to have some kind of model based on training data, right, that allows you to flag that and then potentially send a signal back to, well, let's say even just inside the tractor, first of all, some kind of warning light, right? That always has an input, and you're just changing the way that that's processed. But I think probably the way that more people are talking about it is, especially for doing video or image analysis and moving the location for compute down to a microcontroller or potentially embedded Linux application processor, which has the same benefits whether you're doing a lot of compute or if you are doing a smaller amount and kind of sensor fusion type stuff, which is you're just cutting out that network transmission to get the data all the way back to a server somewhere. crunch the numbers and send the result back, you can do it locally instead, basically. So it's going to be faster. You're going to save time and energy that you would have spent sending all that data up and down.
Yeah.
And you're going to be able to get those results more quickly and then send potentially just the results back to a central location where you can monitor that across a fleet. So for things like image analysis, that has to be done locally because the latency otherwise is just potentially way too slow. Obviously think about automotive would be kind of an extreme example.
Yep.
But then you also have the potential for much more low power devices, which transmitting megabytes of data per day would just drain the battery or not allow you to do it if it's using some kind of energy harvesting technique. So by doing a small amount locally and just sending back just what's needed, that's going to allow you to run, for a lot longer at lower power budgets. So they're quite different applications that you're looking at. I think Edge covers all of them. And there's potentially kind of different tools that are going to come into play as you look at those different applications.
Yeah.
Does that help explain what Edge is?
Well, and I think about, there's so if you go to a conference like CES in Las Vegas and like the computer electronics, and so that AI on the edge aspect of it, actually, from this conference, is like, this is how, hey, we're doing this, and these are the boards, and this is the technology that we're using, and here's a package that you can use on your systems to do the same thing. And that overlap with what's happening at CES, which is like, here, we have a robot vacuum that is using AI to detect it when it's dog feces, so it doesn't track it through your entire house. It's like, oh, dog poop, and then moves around it. You don't have to write an algorithm that specifically identifies dog poop. We've fed 1 million pictures of dog poop to it, and it knows now, and because it's running this specific GPU out there, it can actually figure it out and not run your battery all the way down. So I think that's really interesting with that kind of overlap between those two. Here's the use case and here's what is valuable, and then here's how to actually do it and how you can put this into your own products to make this work. Did you see people talking about using AI for we talked about process improvements? Were people talking about using something like Code Llama or Copilot or anything like that to actually speed up the development process on the process side of these devices?
Yeah, I've seen it talked about in terms of software development and how can we use these kind of tools. I guess one way that it can be added relatively quickly is basically as a form of static analysis, right? That you can put into your build pipeline and potentially run it against and try and find errors in a more human readable way, I suppose, because we already have cyclomatic complexity and Misra and all these kind of things, but they're sometimes a little bit disconnected from the actual code, or what you might want it to look like, and how actually understandable it is. So somewhere like that I can see as a potential kind of drop in, because it's not necessarily enforcing things, right? And it's not making modifications to your code. I mean, I think especially in regulated industries, people are a bit apprehensive about this because you have to ultimately take responsibility for the code that you have, right? And that's becomes part of your firmware. And so if you're not writing every single line, you're already running into issues. I mean, this is already an issue with any third-party libraries that you want to include in your code. You have to go through this process. And I've known engineers to look at that trade-off and say, well, we don't necessarily feel comfortable validating this library, so we're just going to take a piece that we need and basically just focus on that and write it ourselves.
Oh my gosh! And this is how
this is how you get between that and AI. Right?
This is how you get roll your own crypto. Like we still say this, like don't roll your own crypto, and people are like, well, I don't want to trust that library, so to be more compliant, I'm going to roll my own crypto. I'm like, that makes you less secure, but it makes me more compliant. I'm like,
Yeah, I agree, and I think some of the attitudes around that are changing, and it's also, a tool like Zephyr um, kind of embodies potentially the software first thought, right? In terms of how we can make this easier. And the fact that it is open source by nature and also getting support from the vendors, I think is yeah, going to push that attitude forward further, right? To say, well, we are going to have a lot of eyes on this, which are going to try and share usage of software components around all of those kind of things. And then you've got something like Rust coming along and enforcing, more guarantees about the code and making it easier also to integrate third-party libraries, which is going to potentially keep pushing that needle further, right? I guess if you push it all the way, maybe AI kind of does come back into play.
Yeah.
Yeah, I think definitely using it for analyzing your code, doing kind of fuzz testing type activities, potentially, test generation to a certain extent would be pretty useful.
Yeah, I've in conversations that I've had with, I don't know, people who are outside the industry, but adjacent, I've talked about, they're at an application level, they're talking about a lot about like AI is going to be writing code, AI is going to be writing the code, AI is going to be writing the code. But then you talk about it like, no, I'm liable as a company for the compliance of this thing. I can't just let AI write the code. And I'm kind of standing here watching. I'm like, well, you have to be able to test the code regardless if you write it or if the AI writes it. But if the AI writes it, you especially need to be able to test the code. And so that's where you need a robust testing framework, something like what GitLab's talking about. I heard GitHub was kind of, I've seen some articles, they were here 3 years ago. They were not here around and Microsoft wasn't there. So it's like, who else is looking at this from that standpoint? Because of the AI assisted writing, you need a better testing framework. You absolutely need to have a more modern, the software guys need to come in and be like, okay, you're writing software now. Like this is a thing we're totally doing. And yeah, and then you get companies like Zephyr or groups like Zephyr or like Foundries who are just like, okay, here's something you can rely on that's going to be solid. And then everything you do on top of that, like we can help you kind of integrate that all in and make sure that you're getting stuff out there. And it's safe and it's secure. No, please.
One place I did see AI used, which has been around for a few years, but there are interestingly a few companies there doing it this year, was for schematic design and part selection.
Yeah.
Where they're, using the AI as a kind of parametric search optimization function. So you can put in, I have this MCU and I want to measure temperature and pressure and be network capable, for example. And I want to optimize the power budget of my board more than I care about the cost or something like that.
Yeah.
And it will then basically do a part search and provide you with some options and also generates a schematic for you, which you can then import into an EDA tool, like Altium or KiCad. So there's a couple of companies around doing that. And, they have, in my mind, they have a lot of potential because I do think people spend potentially too much time doing that kind of work. But when I've spoken to EEs in the industry who see that's kind of their job, I think sometimes that they do see it as encroaching on their decision making, and also running up against issues that we're talking about for third-party libraries in terms of validating not just the decisions that the model has made, but some of the input parameters, essentially how accurate the data in those databases is that the AI is choosing from. As a simple example, if you're going to have a schematic which says which pins need to be connected to which power rails and which inputs on your MCU, you probably want those to be right. And they aren't always, right? Regardless of where you get the design from.
Oh my God.
So then they ask the question of, am I just going to spend more time checking that schematic is right than I would have done in the first place?
Yeah.
But the output of that ultimately is a schematic that can be checked by hand by someone who's knowledgeable.
Yeah.
Um, and I think there's potential for also joining those tools up with something like Zephyr and actually reducing the opportunity for mistakes, because you can tie part of the software implementation. If we take embedded Linux or Zephyr, which have the device tree model, if you can tie that more directly to a schematic design, so it's slightly separate than the AI component, but I think it has a lot of potential to, actually reduce errors in embedded systems development. You mentioned you've been to CES.
Yeah.
I've never been there. That's out in Las Vegas,
Hmm.
right?
Yeah.
Big
Oh
conference,
my God.
big opportunity to sell. And like I said, we do have stands like that at Embedded World.
Oh
Very
yeah.
big stands filled with essentially salespeople, non-engineers, let's say. But I think I always find it interesting just walking around some of those smaller stands and finding companies that you haven't heard of before, listening to a bit about what they do and their perspective, because they do tend to be filled with engineers who
Yeah.
are interested in the same concepts. So, did you find that as well? I mean, how is it different to a conference like
Oh my
CES
gosh.
from the standpoint of an engineer?
So the last few years of my conference, like you should, here's my conference attendance for the last few years. Black Hat, cybersecurity, DEF CON, RSA, CES, and Embedded World. And like and when you look at the diversity of like what's going on in each one of these things, they're all so very different, but they're all talking about very similar things in the technology space. How is AI affecting the way we're doing things? How are people using these devices and embedded systems that we are trusting so much with so much of our lives? CS was really interesting to me because of how big it is, but then how many of these tiny vendors there are. Like even in Embedded World, they had a number of like small vendors, but they weren't nearly as small as like they had an entire, I don't know, ballroom size. It was just the entire conference center just filled with these tiny from different countries, and like here's the entire French delegation of all these different countries that came over from France, and they all get this tiny little
Okay, yeah,
space to just go, and it's like, oh my gosh. Um, but then they also had it broken out into fintech and automotive, and it was just wild, just the different things. So when I was at CES, I'm interested in talking to the engineers more. So I was just walking around looking for people who had PCBs. If you brought a PCB with you as part of your demo, you brought an engineer. You're not putting a salesperson holding a PCB and explaining what's like. Okay, so then that's how I met the guys from Ottawa Entertainment who were actually at this conference at Embedded World as well. I spent a good amount of time with those guys. So like if you brought a PCB, that's how I could tell you were an engineer. Now I went to this one and I honestly, that was not guaranteed that you were going to get an engineer if there was a PCB.
there's a lot of PCBs at Embedded World, that's
There
for
are
sure.
tons of them. And I talked the number of folks that I talked to, I'm like, oh, you're just a salesperson. Like, yeah. Like, do you have any engineers here? No, no, we're selling this PCB. And I'm like, oh, okay, got it. That's how I should talk to your customers. Okay, let's see.
Yeah,
So it was very different, but a lot of overlaps too. And then the security conferences are also um, very different. I think the defensive security conference folks are very focused on application level and what most people interact with on a daily basis, which is kind of web apps and stuff that's on your phone. And so
sure.
they're interested in that kind of stuff. There's a few companies that are out there that are doing operational security and mitigation, and that's another big thing. But most of that stuff is focused on desktop and server kind of stuff. There's only a couple companies that are interested in operational technology, which is kind of trying to secure manufacturing facilities and refrigerators and that kind of stuff. Like, but they're very much in the minority when it comes from the security standpoint. And so like trying to bridge the gap between those two spaces is just, I don't know, it's going to be a long time because, hey, with the CRA, that's great. No more default passwords. Like it's 2025. Are you kidding me? Like people are still
Right.
just dumping strings and then replacing your firmware. Like that's what's happening still. Like, but the impact of that is very different than a ransomware of a hospital. And like hospitals are not getting ransomware by their infusion pumps. They're getting ransomware by the desktop computers that are running Windows and connecting to a Windows domain controller. So, and people clicking on email links. So like from the security standpoint, you should be focused on that.
Yeah.
Now, from an embedded, like trying to make embedded secure, like I'm worried about those infusion pumps and those, and the watches and the heart rate monitors and the blood typing machines and like that kind of stuff. But that's not where people are getting hacked. That's not where the money is being spent to try to fix these things. So it's really, I don't know, it's really interesting. And then like seeing, okay, DevSecOps, let's get there. Let's actually move in this direction and see the number of vendors that are kind of pushing that. Let's get some compliance. Let's do some static analysis tools. How are you guys trying to use AI? Are the people that are going to be comfortable having AI help write their business logic? If they're comfortable doing that, are they going to be able to get to market faster? Are they going to be able to do that? Well, how are they going to be able to create code and create these products that they can then trust and rely on that are going to pass these compliance standards that are coming forward? So I think there's a lot of unanswered questions, and I don't know, I'm excited about the whole thing.
Yeah, no, there is a lot going on. I think embedded engineers are faced with quite a wide variety of challenges at the moment.
Yeah.
And not necessarily with the experience or tooling or simply the range of roles and the number of engineers that are dedicated to the problem in the wider software world.
Yeah.
Because the number of possible attack vectors, the number of things that can go wrong in an embedded system, and the potential consequences of those are all quite big. But the amount of resources, human resources, and like I said, the tooling and
the expertise.
support,
like if you're really good at this part of it, but you don't like, that takes a lot to be a
Yeah.
really good electrical engineer. But now
right?
you're being asked to write software because we're
Well,
using
and
AI
I
to generate
think
schematics. And it's like,
the mindset from engineers, but also from management about how to build embedded systems has not necessarily kept up to pace with the challenge, because a lot of people think about just making a really small 8-bit microcontroller work, that's going to be flashed once
yeah,
on a specific date, and then 100,000 of those are going to be made all exactly the same,
sounds perfect.
and never updated again, right? And never have problems. And that's not really the way that the world works anymore. So I do see a lot of potential for integration. I suppose it would be vertical integration, right, between kind of vendors, tool chains, people providing security and analysis solutions, and then all the way down to deployment. So there are companies making system or modules, for example,
Yeah.
and providing those with, like you said, pre-packaged Linux distributions that already have a bunch of security on by default,
Yeah.
and providing you a way to immediately hook that up from an untrusted environment straight to your trusted environment in the cloud, where you can then deploy your actual firmware payload onto it,
Yeah.
and continue to receive data in a trusted manner, and provide further updates and so on. And the amount of time, energy, headaches that has the potential to save
Yes.
is quite significant.
Yeah.
So I hope we're going to see more people, more companies offering that in a really good and usable way, not just in a demo way.
Yeah. Yeah.
And more engineers and companies looking to that as a way to secure, their product, but also to get to market faster and more effectively.
Yep. Yep. Excellent. Well said, sir. Excellent chatting with you, sir. This has been the Magpie in the
Something like
Tree,
that.
something like that.